Today I will explain a problem related to the Pelton turbine. So this is from question paper May 2019. Go to the May 2019 question paper, university question paper. So this is the question. A Pelton wheel is to be designed for a head of 60 meter. So head is given, it is 60 meter. When running at 200 rpm, this is 200, speed is 200 rpm, then the Pelton wheel develops 95.6475 kilowatt shaft power. The velocity of the buckets is 0.45 times the velocity of the jet. Then the overall efficiency is given 0.85 and coefficient of velocity is 0.8, and the marks of this problem is 6. Okay, we have to solve this problem. This is actually a direct problem from R.K. Bensal textbook. You can see the problem number 18.11. So when we design a Pelton wheel, the following data is to be determined. We have to determine the following datas. Okay, the datas we have to find is the diameter of the jet, small d, then the diameter of the wheel, capital D, then width of the buckets, which is equal to 5 into d, and the depth of the buckets, which is 1.2 into d, and the number of buckets on the wheel. So we have to find all these values if a problem is design of a Pelton wheel. Okay, so this is the problem. This is the direct problem. You can see this is the head is 60 meter. You can see the head is 60 meter when running at 200 rpm. So 200 rpm develops 95.6475 okay, shaft power. Then velocity of buckets is 0.45 times the velocity of jet. Then overall efficiency is 0.85 and the coefficient of velocity is 0.98. Okay, so the given data are, first of all, the head is given 60 meter, so we have to write head h is equal to 60 meter. Then this is speed is given 200 rpm, so n is equal to 200 rpm. Then the shaft power is given, it is 95 point, this is the shaft power, 95.6475 kilowatt. Then velocity of the bucket, so velocity of the bucket is equal to 0.45 times the velocity of the jet. We have to write the relation. Velocity of bucket is equal to 0.45 times the velocity of the jet. Then the overall efficiency is 0.85, so overall efficiency 0.85, and coefficient of velocity is CV, that is 0.98. Okay, so design of Pelton wheel means we have to find the diameter of the jet, diameter of the wheel, width and depth of the buckets, and the number of buckets on the wheel. So first we have to find the value of the velocity of the jet. Okay, so the equation, I will show you the equation. The velocity of the jet, this is the equation, velocity of the jet. Okay, this is the equation. The velocity of the jet is given by v1 is equal to cv into root of 2gh. Okay, this is the equation. So we have to substitute this equation. Yeah, velocity of the jet is equal to v1 into cv into root of 2g. cv means coefficient of velocity, so coefficient of velocity is given, that is 0.98. so cv, so coefficient of velocity is 0.98, so 2 into root of 2 into g is 9.81. h is given, the value of h is equal to 60 meter. Okay, so you will get the value of v1, 33.62 meter per second. Then bucket velocity u is equal to u1 is equal to u2, and here this is given as the bucket velocity is given as 0.45 into v1, so 0.45 times the velocity of the jet, so 0.45 into v1, so 0.45 into, so v1 is 33.62, so you will get the bucket velocity 15.13. Then there is another equation of bucket u. The equation of u I will show you. You can see this is the equation. u is equal to pi dn by 60. This is the equation, another equation. U is equal to pi dn by 60. Okay, so I will show you. Yeah. Okay. Okay, so here u is equal to pi dn by 60, where d is the diameter of the wheel. Okay, so here you know the value of u is 15.13 and pi into d into n is 200, so you will get the value of 1.44. So you will get the diameter of the wheel. So diameter of the wheel is 1.44 meter. The next is the diameter of the jet. Okay, so the overall efficiency is given. Overall efficiency is 0.85. So what is the equation of overall efficiency? Overall efficiency is equal to shaft power divided by water power. So shaft power is given 95.6475 and water power is, you know what is the equation of water power? Rho GQH by 1000. Rho GQH by 1000. You can see rho GQH by 1000. So in this you have to substitute the values of everything. Okay, and you will get the value of Q. So here overall efficiency is given. Okay, here overall efficiency is given. Okay, so here overall efficiency is given, then shaft power is given, then what is the value of rho? So rho is rho, you know, then G you know, H you know, so you have to find the value of Q, discharge value. Okay, so you will get discharge is 0.1912 meter cube per second. Then but the discharge Q is equal to area into A into V, area of the jet into velocity of the jet. This is another equation, area of the jet into velocity of the jet. So discharge value is substitute the discharge value here, and you area of the jet is area means pi by 4 d square into velocity of the jet is v1. Okay, so velocity of the jet we know 33.62. okay, so discharge is equal to area of the jet, that is pi by 4 d square into v1. V1 is the velocity of jet. Okay, so that is equal to pi by 4 d square into 33.62. so from this you will get the value of small d. Okay, so that is the diameter of the jet. Okay, so from this, with this you can find the value of the size of the bucket. Size of the bucket means the width of the bucket and depth of the bucket. The equation is width of the bucket is 5 into d, so that is 425, and depth of the bucket is 1 point into d, so 1 point into d you will get 102. Then the number of buckets on the wheel is given by the equation Z is, this is the equation, Z is equal to 15 plus d by 2d, so that is equal to 15 plus d is 1.44, the value of d is 1.44, and divide by 2 into small d, so small d is equal to 85 mm, so that means 0.085 meter, so you will get the value of 23.5, say 24. Okay, so this is the number of buckets. So in this way you can solve the problem of Pelton wheel. Design a Pelton wheel problem. So once again, if the problem is related to the design of Pelton wheel, if the question is a design of Pelton wheel, you have to find what is the diameter of the jet, what is the diameter of the wheel, then size of the bucket, that is width and depth of the bucket, and the number of how many buckets, number of buckets. So you have to find all these values. Okay, so do this problem. Thank you.